Um, Good day, guys. This video you're watching is brought to you by Shelfik, and feel free to subscribe to the YouTube channels, forward it to your friend as well to benefit from this wonderful video. So today we'll be talking about mole concepts. Mole concepts is such one of the greatest and interesting topic in chemistry because it does not mean whether you are still developing chemistry or whether you are advanced. I can tell you, chemistry deal with measurement, and measurement of substance is actually measuring mole. It shows that mole is very important and very essential. So this topic is quite very simple. So because we are looking at mole concepts, and mole concept simply refers to as many ways by which mole can be found. And I can tell you that this mole is quite very interesting because why it is developed by one of the greatest scientists ever, which is known as Amedio Avogadros. So Amedio Avogadros actually did a great job in ameliorating the meaning of mole. He thought about it. It was like, yes, if we have non-living things, if we have living things, it was like everything in the whole world must have something in common. And for the first time, so this scientist was able to connect everything in the whole universe. So he stated that one mole of any substance should have something in common, and that is what we call the Avogadro's number. So from the Avogadro's mentality, one mole of any substance should be equal to the Avogadro's number, and that's what we are going to be looking at. So at the end of this topic, every student that watch this video are meant to know the meaning of Avogadro's number, the meaning of mole, and also to be able to solve any questions under mole concept, and also to know how to use any of the mole concepts and in solving any question they want to solve. And as well, I want you guys to feel free sit down, follow me up with your pen, your jotter, and your calculator. And if you have any question, feel free to drop your questions on the comment section. And like I said, don't forget to subscribe and forward it to your friends as well. So we move. So like I said earlier, that this particular idea or mentality is discovered by a scientist known as Amedio Avogadros. So before we move ahead, it will be so good of us to actually understand what is meant by mole. So mole is the amount of any substance. Is the amount of any substance. If you are good in physics, you will see that in the beginning of physics, we have seven fundamental quantities. That is, they are quantities that are independent of every other quantity. They are the beginning quantities. So one of these quantities is the amount of substance, and you remember that the amount of substance is measured in mole. Yes, just like how cell is very important to biology, how motion is very important to physics. So likewise, mole is very important to chemistry. So irrespective of any examination body you are solving or you are dealing with, so there is high probability that question will be asked on mole concepts. So mole concepts tell us how mole can be found. And if you are talking about mole tell us the amount of substance. So amount of substance can be in form of gram, it can be in form of dm cube, it can also be in form of gram per dm cube, and it can also be in form of mole, and it can also be in form of mole per dm cube. So at the end of this topic, we are meant to know all these things and be able to solve. Now before that, we are meant to know some little things that are very essential in our solving. So one of the things we'll be encountering is the understanding of molecular mass. Yes, as a student and you are watching this video, you are meant to know molecular mass of element from element 1 up to element 30 actually. But if you know it up to element 20, I would say that yes, that's still a good grade. But actually, I would advise you to go and know from scandium down to zinc, that is from 21 to 30. So this will help you and it will goes a long way in your calculation. So if you have any question, like I said, feel free to drop it under the comment section. And as well, if you need any tutoring or mentorship, so feel free to contact me through my contact or through my Gmail. So now let's continue. So from the mentality, we have seen that mole refers to as the amount of substance. So according to Amedio Avogadros, yes, I love what he did actually. For the first time, let's say we have a freezer, we have a television, and we have a blender. So normally, sincerely speaking, these guys, in terms of physics, if you were to look at them, the only thing that connect all of them together is that they are all electrical appliances. But in chemistry, nothing connect them together because they don't show anything. But for the first time in chemistry, one person was able to observe that no, it's not meant to be like this. Every object in the universe are not meant to be different. There should be something that will connect every element or every substances together. And for the first time, Amedeo Avogadro discovered that there is a connection between every substance in the whole world, and he called that the Avogadro's number. And the Avogadro's number is 6.02 times 10 raised to power 23. Now, so not actually living here. So we can actually bring this particular mentality into biology as well. Look at biology. Normally, biologists will tell you that there is no similarities between living things and non-living things. But for example, if you have studied to many extent, you will see that there is a similarities between living things and non-living things. And one of the similarity is the increase in biomass. Whether you like it or not, both living things and non-living things increases somehow. For example, if you put a cassava flakes, another word, a salt, if you put a salt inside water, you will see that there will be an increase in the volume of the salt. So the same thing, every living organism also increase. So Noah, so there is increase in our biomass, both living things and non-living things. So it means that one of the similarities about living things and non-living things is the increase in biomass. So that actually deal with the mentality of Avogadro's as well. He thought about it and it was like every substances in the whole world must be able to have the same things, and he gave them the Avogadro's number. So now you have to know that mole, it is being measured in respect to carbon 12. So carbon 12 was one of the major elements used by Avogadro doing his experiment. So he measured everything according to the carbon 12. So question can actually come in, and you have to know that 1 mole of any substance, 1 mole of any substance will give you Avogadro's number. So we are still going back to that, and before I move on, I have defined a mole for you. So let's move on. So in case you need a definition in a written form, so we can write. So mole is the amount of substance, so which contain as many Avogadro's entities as there are carbon 12, as there are carbon, okay, as there are 12 gram in carbon 12. So you can put it this way: is the amount of solid which contains as many Avogadro's entities as there are 12 gram in carbon 12. Yes, so this particular idea comes from the fact that if you look at carbon, a carbon has atomic number of 6 and the molecular mass is 12. So there is a strange uniqueness about carbon. So you can read that from your textbook. So one of the uniqueness of carbon is that it is one of the most abundant elements in the earth crust. Yes, there's nowhere in the whole world where you will not find carbon from. Carbon can be found from paper, from wood, from many things, even from living organisms. So Amedeo Avogadro performed most of his experiments using carbon as a reference point. So the mole concept, like I said, refers to as many ways by which mole can be found, and one of these ways is using relative molecular method, the formula method, the Avogadro's entities, using volume at STP, and using dilution formula. So at the end of this topic, it is expected of every student that watched this video to be able to solve any questions under the relative molecular formula. Under the mole concept. Now, it is very important to understand how all these things goes. Now, the number one thing to note is the first one that says using the relative molecular mass. Yes, to use the relative molecular mass, like I said, that we need to understand how to find molecular mass of elements. So for you to do that, you need to know the molecular masses of elements from 1 to 20. But I told you that you can extend it to from 1 to 30. That is from hydrogen to zinc. But we still know 1 hydrogen to calcium, so we are still good to go. Now, so using relative molecular mass formula, it is a theoretical approach, I repeat again, is a theoretical approach. Yes, because in here you will be talking, like it's more of saying you are talking. So that is what the meaning of the theoretical approach mean. So let's look at it. So theoretical approach, it tells you about you saying something. So for example, you need to know the most important thing to understand is that 1 mole of any substance, so please take note of that, 1 mole of any substance will give you the exact molecular mass. So 1 mole of any substance will give you the exact molecular mass. So 1 mole of any substance will give you the exact molecular mass. So I believe if I'm talking about molecular mass now, you should understand what molecular means. And if you don't understand what molecular mass means, kindly follow me and let's look at molecular mass of few elements together. For example, molecular mass of H2SO4. How do we find molecular mass of H2SO4? So here it means we have 2 of hydrogen plus sulfur and plus 4 of oxygen. So what do we have for 2 of hydrogen? So hydrogen is 1, so plus sulfur is 32, so plus 4, and oxygen is 16. And from here we have 2 plus 32 plus 64, and at the end of the day we should have 98. So molar mass is measured in gram per mole or gram. So you can see how molecular mass is formed. So if you want to copy this, feel free to pause the video and copy it. So let's look at it in another way. Let's say we want to find molar mass of HCl, the molar mass of HCl. So to find molar mass of HCl, so don't forget hydrogen is 1 and chlorine is 35.5. As you can see, I'm telling you all this value of found because you have to know all this value of found. So in some question you'll be given, but don't be deceived in chemistry. There are some areas where you will need this thing and you will not be given. So then from here, we have seen how to calculate molecular formula. Then believe me, to solve anything in this mole concept, it becomes so easy. Don't forget, in sum of everything I've said so far, that mole is the amount of substance which contains as many Avogadro's entity as they are 12 grams in carbon 12. So we move. So now on getting to this particular aspect, so for the relative molecular mass method, so now let's use it to solve an example 1. So solution. So we are asked to calculate the mole of sodium present in 58.5 grams of the substance. So calculate the mole of sodium present in 58.5 grams of the substance. Now, please, I just need you to follow me. This work is very simple, and please follow me. So once you can follow me, at the end of this topic, I can bed it with you. You can solve any question on that is. So the question says that calculate the mole of sodium present in 58.5 grams of this or the substance. Now, the number one thing is that you need to understand the substance you are dealing with. In this particular aspect, the substance you are dealing with is the sodium chloride. So, like I told you, you will always need their molecular formula. So, sodium chloride means sodium plus chlorine, and sodium is 23 and chlorine is 35.5. So then how did I know all this value? I've told you need to know it. Sodium is 23, chlorine is 35.5. Other one that may be needed in the course of this teaching is oxygen. Oxygen is 16. Then from there sulfur is 32. So hydrogen is 1 in case we need them. So from here, if you calculate, we are going to have 58.5. It means that the molecular mass of this substance I want to deal with is 58.5. Then having done that, then I will move ahead and come to this particular axis and state it here that 1 mole of the substance I'm working with, don't forget what I told you earlier. I have told you that 1 mole of any substance must give you the exact molecular mass of that thing. So 1 mole of sodium chloride, what does the 1 mole gives me? So the 1 mole of sodium chloride for my calculation should give me 58.5 grams. So but I'm asked to find the mole. Look at it from the question. So the question asks me to find the mole. I should find the mole that will give me 58. That is mole that will present 58 grams, or mole that are present in 58. So I don't know the mole that will give me 58
0.5 gram. And even using the relationship, you should know that the answer should be 1. But what I always tell students to do is that when you get to this point, just cross multiply. So 1 times x should give you 58.5. So x times 58.5 will give you x 58.5. So you divide both sides by 58.5 and you divide both sides by 58.5. At the end of the day, you will see that the x is equal to 1. So that is it. So this is how to find it. So relative molecular mass is not a formula method. So this is what you'll be doing. Just 1 mole give 58.5, x give 58.5. Yes, and you can be someone that loves writing. Yes, if you are someone that loves writing, you may actually love to put it in word, but believe me, any of this formula is actually accepted by any teacher. You can then put it in word and say 1 mole of sodium chloride required or contain. You can say that 1 mole of so this one require you forming words by yourself. So you can say that 1 mole of sodium chloride contain 58.5 gram. Then you say that x mole of sodium chloride so will contain 58 so you don't know, so you cross multiply. It's still the same thing, but believe me, sometimes you may not really know what to write, so it is always good so for you to just practice using an equivalent of proportion. So you say 1 mole give you 58.5, so nobody will penalize you for that. And you don't know the one, so you can see the trend of how I did it. So the trend is that mass under mass, mole under mass, mole under mole, there must be there must be a correlation. Mole, mass, it can be volume, do you understand? So they have to be together. So you can see that from the number 1 expression, so using the relative molecular mass formula, so we got 1 mole as our answer. So we move on to the number 2 aspect of it. So the question says that calculate the mass of H2SO4 that is present in 0.5 mole of the substance. The question says that calculate the mass of H2SO4 present in 0.5. So this is quite very easy to do. So the first thing we need to do is to find the relative molecular mass of the sodium chloride. So we find the relative molecular mass of the sodium chloride. So of the H2SO4. So sorry for that. So we find the relative molecular mass of H2SO4. So H2, we have actually found it indirectly. Don't forget, H2SO4 contains 2 of hydrogen plus sulfur plus 4 of oxygen. Then from there, hydrogen is 1, sulfur is 32 plus 4 of that is 4 of 16, oxygen 16. Then we have 2 plus 32 plus 64, then that should give you 98 gram per mole. So that is for the H2SO4 for you. So from here, okay, so we will continue from here. So from here, so we have gotten that the molar mass of H2SO4 is equal to 98 gram per mole. Now let's now look at this question. The question tells us that calculate the mass of H2SO4 that is present in 0.5 mole. Don't forget what I told you. Find mass and mole. Mass and mole. And truly, if you look at everything we have been doing, it is actually called mass to mole relationship. Because why? You see that I kept on mentioning that 1 mole of any substance should give you the exact molecular mass. And the exact molecular mass of the sodium chloride here is 58.5. Then I said that I don't know the mole that will give me 58.5. And if you cross multiply, you see that x is equal to 1 mole, which you have solved. So the same thing is actually relative, synonymous to the H2SO4 version of it as well. So we know that 1 mole of any substance should give you the exact molecular formula, and 1 mole of H2SO4 should give you the exact molecular mass rather of H2SO4, and the exact molecular mass of H2SO4 is 98 gram. But the question now says that I should find the mass that will give me 0.5 mole. Don't forget, this is where I wrote mass. You can see this side is for mass and this side is for what? Is for mole. So because I'm looking for mass, I'll write there calculate mass. So it means I don't have the mass. They asked me to calculate it. So I should look for mass that will give me under mole. Can you see under mole? So I should look for mass that will give me 0.5 mole. So look for, you can see it is very easy to do. Look for the mass, you can see under mass, look for the mass that will give you 0.5 mole. So one thing you need to know is that always know that 1 mole will give you the exact molecular, exact molecular mass. So 1 mole give 98, then 0.5, we don't know what 0.5. So calculate the mass of what 0.5 will give us. That's meaning, so from here you cross multiply, and if you cross multiply, x is equal to 98 times, this should give you 0.5, and I think that should give you 49 grams. So that is the mass that will be given, so if the mole is 0.5. Now we continue from there. So the next one now, that, so if you want to copy this, feel free to pause the video and copy it. So the next one now is using the formulas method. So using the formulas method, so using the formula method goes a long way, and it is actually the most simplest part of mole concept. I will even say that during my days as an upcoming scholar in chemistry, I will say that one of the formulas I quickly know is using the formula method. So using the formula method is quite very easy. Why? It's because it's just a formula. So all you just need to know or to do is to know the formula. So the formula said that mole is equal to small m all over the capital M. So that's the formula. N is equal to small m all over capital N. So capital M, where the small n represents the mole or the amount of substance, the small m represents the mass of the substance given in the question, while the capital M represents the molar mass. So capital M represents the molar mass. So the using formula method is the same with the first one we did. At the end of the day, you can see that's the reason why I am using the same question. Can you see it? So at the end of the day, we must get 1 for this guy, and we must get 49 for this guy too. So that is it. So that's how you will know whether you are getting it or not. So using the formula method is quite very easy. Understand the question. The question said that calculate the mole of sodium chloride. Calculate the mole of sodium chloride, and the mole of sodium chloride we don't know. We have to find the mole. Can you see it? Present in this, we are given a mass. So the mass, small letter m, is equal to 58.5 grams. So what is the compound we are dealing with? Sodium chloride. So you have to find molecular mass of sodium chloride. We just found it the other time. So sodium is 23 plus 35.5, and that will give you 58.5 grams. So I hope you actually remember how we solved this. Sodium chloride. Sodium is 23 plus 35.5 of chlorine to give 58.5. So the molecular mass now is equal to 58.5 grams. So from there we can then move ahead and solve. So from here, the mole is equal to the mass all over the molar mass. So the mole is equal to 58.5 grams all over 58.5 grams. So at the end of the day, the mole is equal to 1 mole. I hope you can see this. So this is the joy of it. You can see at the end of the day, we got 1 mole as well. So, and don't forget, for the second one we got 49. So for the second one too, we are meant to get 49. So let's solve it. So we are asked to calculate the mass of H2SO4. Find the mass of H2SO4. So it means this time around we are looking for mass, which is small m. Don't forget that capital M is not just a mass, but is a molar mass. So molar mass of H2SO4, we just found it in the number 2 of the relative molecular mass, and we got 98 grams per mole. If you don't understand how I found it, it means 2 of hydrogen plus sulfur plus 4 of oxygen. So that is 2, 1 plus 32 plus 4 of 16. So if you add it together, you will get 98. So from there we continue. So we are given mole from the question. The mole is 0.5 mole. Then from here we have small n to be equal to small m all over capital M. We are looking for the small m. Let's make the small m solve your formula. We cross multiply. Then the small m is equal to small n and capital M. So the small m is equal to, what is the mole? The mole is 0.5 times, what is the capital M? that is 98 gram. So at the end of the day, the small m is equal to 49 gram. And if you remember, if not that I have cleaned this, we got 49 gram as well in this place. So what have we to say about this? It simply means that the molecular formula, the relative molecular formula and the formula method are the same, and truly they are the same. There is nothing different. But it is just quite funny that students always run away from the relative molecular formula. They don't like it. They like using the formula method. Yes, the formula method is good, but I can tell you it is not all the time that the formula method always tends to be open to students, because many times it can be so confusing, and if you are not good in chemistry, you will be able to use it. So it is very good you know the relative molecular formula, because it is from the relative molecular formula the formula method is obtained. So if you understand the relative molecular formula, it means you are understanding the topic. So the next one is using Avogadro's entities. Now you see that for the quiet time when I'll be teaching, I haven't actually spoken about the Avogadro's entity, saying using of 6.02 times 10 to the power 23. Yeah, it is because the reward is actually reserved for the best. The reward is reserved for the best. So yes, Avogadro's, I told you that Avogadro's connected a number to every substance, whether living or not living, and that number is 6.02 times 10 raised to the power 23. So this is the number he connected to every substance in the whole world. And what does Avogadro's try to bring out? So please, you are to know that you are to use Avogadro's number. You see, this is, I would say that when I was growing up as a chemistry student, this is the thing I didn't know. Because many times I will see a question at the back of the textbook, and I will be like, wow, this question is so easy, I will get it, I will do this. At the end of the day, I will just realize that I didn't get it. And the issue is always that most time in the past question, they will use Avogadro's number. I will not use it. Most time I will use it and they will not use it. It's because I don't understand when to use. I can tell you this, many students knows that Avogadro's number is 6.02 times 10 to the power 23, but not all students can know when to use it. So please, at the end of this topic, you are meant to know when to use Avogadro's. Now imagine Avogadro's package to be imagine Avogadro's number to be like a carton. So it's like a carton, and inside the carton it is said that anything that comes out from the carton must contain Avogadro's number. And at the end of the day, what come out of the cartons are ions, they are molecules, they are atoms, they are electrons, and they are protons. So it simply means that anytime a question asks you to find the number of mole, or all the one you have been solving, I've been mentioning find the number of mole, find the number of mole. Good. But I've not asked you to find the number of ions. So the moment you are asked to find the number of ions, the moment you are asked to find the number of molecules, the moment you are asked to find the number of atoms, the moment you are asked to find the number of electron or proton. So these are called Avogadro's packages. So anytime a question mentions Avogadro's packages, don't waste your time. You are to use Avogadro's number. You see, these are the secret that nobody will tell you. Even textbook won't explain it this way. So you are meant to know that anytime you are asked to find Avogadro's Avogadro's packages. And what are the Avogadro's packages? Ions, molecules, electrons, and protons. So if a question mentions ions, if a question mentions molecules, if a question mentions atom, and ask me to do something on them, it means I'm going to use Avogadro's number. So which will actually be different. So in fact, I can remember I tried many ways to know this back then when I was in secondary school. I couldn't grab it because yes, no textbook explained this way. It was after many years I realized that I'm meant to use Avogadro's number anytime I'm dealing with Avogadro's family or packages. And what are the family of Avogadro's? Ions, molecules, atoms, and electrons. So please take note, this is the most important summary of everything I'm saying. You are to use Avogadro's number when dealing with Avogadro's entities or packages. And what are the entities? Try to know them. Ions, molecules, atom, electron, and proton. So you will see that so far so good, all the questions I'll be talking about, they did not mention molecule, they did not mention atom. Can you see it? They did not measure all these things. So it means Yes, let me give you a question that may look like what I'm trying to say, but it's not the same thing with what I'm trying to say. So I want to give you a question that may look like it, but it is not it. So let's look at this question together. So let's look at this question together. So let's say that a question says that calculate the mass. Okay, calculate the mass. Calculate the mass. Okay, calculate the number of mole. So I want you to look at this. It is not the same thing. Take note. Calculate the number of mole present in in 12. Okay, let's say in 17. I'm looking for a better thing to use. In 284 gram. In 284 gram. Calculate the number of mole present in 284 gram of chlorine molecule. Yes, this is a good question, and it comes to my mind. That's the reason why I am writing it out now. Please, you need to understand these questions. So, because the question mentioned molecules does not mean you should use Avogadro's entities. Please pay attention. The question says we should find the number of mole. Okay, but here you need to understand that if the question mentions chlorine molecules means Cl2. If a question says hydrogen molecule, it means H2. If a question says oxygen molecule, it means O2. Fluorine molecules, F2. Nitrogen molecule, N2. That is the meaning. Because why? If atom reacts with atom, it's going to give you molecules. So molecule is the combination of atoms. So for this particular question, so please, you are not using Avogadro's constant, because here the molecules, chlorine molecules means another thing. Chlorine molecule simply means that Cl2. Yeah, so we cannot find this. Calculate the number of mole present in chlorine molecule. So you need to understand that chlorine molecule is Cl2, and a single chlorine is 35.5. So times 2 will give you 71. So we can then solve. So we know that 1 mole of chlorine molecule contain what? 71 gram. But we don't know the mole that will give us 284 gram. So we don't know the mole that will give us 284 gram. So you cross multiply. So it will be x times 71 is equal to 284 times 1. So we give it 284. So you divide both sides by 71 and 71. So our x will be 284 divided by 71. So which you can then calculate. I hope that area is clear to you. But now let's now see the difference in the question. So I hope you understand what I'm trying to say, that in this aspect the chlorine molecules mean Cl2. Now, so like I said, that we are to use Avogadro's number, which is 6.02. So Avogadro's number is 6.02 times 10 raised to power 23. So anytime we are asked to find any of the Avogadro's entities. So anytime we are asked to find any of the Avogadro's entities, we use the Avogadro's number. So now let's look at the question number 1. So you will see that this is a beautiful question indeed, because you can see the question. The question asks us to calculate the number of molecules. Wow! For the first time we are asked to find number of molecules. All the one we have been solving is just number of mole. But this one is number of molecules. Now you need to think about the molecules. Like, is the molecule part of Avogadro's entity? Yes, it's part of Avogadro's entities. So it means you are going to use you are going to use mole. That is, you are going to use 6.02 times 10 power 3. So calculate the number of molecules that is found in what? In 2 mole. So solution. You see, in this type of question, you don't even need molar mass. Why? Because the question does not measure mass. If the question measures mass now, you need molar mass. So the question does not measure molar mass. It just talks about what? Mole. This question is very simple. Very simple. Yes, it is very simple. You have to find the number of molecules present in 2 moles. So you know that 1 mole of any substance should give you, what? 6.02 times 10 raised to power 23 what? Molecules, or Avogadro's number. So 1 mole should give you But they now say that you should find the number of molecules that will be present in what? 2 moles. 2 mole, you don't know what 2 mole will give you. Can you see molecule under molecule? This side is for molecule, this side is for mole. So anyhow you want to do it, you can reverse it in other case. It's still the same thing. So 1 mole gives 6.02 times 10 to the power 3, but you don't know what 2 mole will give. Now the question is that if you look at how beautiful this question is, this question doesn't tell me to use 6.02 times 10 to the power 23, but because I know that anytime you are asked to find this guy, because it's an Avogadro's package, I will use 6.02 times 10 to the power 23. So here you cross multiply. So 1 times x will give you x. Then 2 times this will give you 12.04 times 10 raised to the power 23, which is the same thing as x equal to 1.204 times 10 raised to the power 24. So at the end of the day, you will see that if 1 mole produce 6.02, then 2 will produce 2 times of it. So you can see how beautiful this question is. And how did I know that I will use 6.02 times 10 to the power 3? Because it is, this guy is measuring Avogadro's particles or entities. So the next one, the question says that calculate the number of atoms. Yes, if you look at atoms as well, atom is part of Avogadro's entities. So which simply means I'm also using 6.02 times 10 raised to the power 23. I hope you can see how beautiful the question is. Now you need to pay attention. So the question is calculate the number of atoms present. Now you can see in this one now, they are using gram. They are using gram in this question. Now from what I've taught you that 1 mole of any substance should be equal to its exact molecular mass, right? And I've also taught you that 1 mole of any substance should be equal to 6.02 times 10 to the power what? 23. Good. So if 1 mole of any substance is equal to its exact molecular mass, and 1 mole is also equal to 6.02 times 10 to the power 3, it means that the exact molecular mass of any substance should also be equal to what? 6.02 times 10 to the power what? 23. I hope you're getting the formation. If 1 mole is equal to exact molecular mass, and 1 mole is also equal to 6.02 times 10 to the power 3, then exact molecular mass is equal to 6.02 times 10 to the power 3. The reason why I am giving you this particular hint is that you will not have to stress yourself finding mole doing. You see, you need to understand relationship between questions. And if you are to look at this question now, the relationship between this question is that they are asking Avogadro's entity and mass. That's what they need. So now we know that H2SO4, we know that 1 mole of H2SO4 contain, we just saw that it contains 98 what gram. We have used that for number 2 of number 1, number 2 of number 2. So we are also using it here. So now we know that 1 mole is, okay, look at it. This is what I'm trying to say. You know that from what I've explained to you guys, that 1 mole of any substance will contain 6.02 times 10 raised to the power 23. Good. So instead of writing 1 mole, we know that 1 mole is the same thing as what? 98 grams. So we just replace it back. So we know that 1 mole is 98. So this is what we call mass to atom relationship, or mass to Avogadro's entity relationship. So instead of using mole, wasting my time first get the mole and be using, so it's a stress. So I can just say that the 98 gram will give me 6.02 times 10 to the power 23. Then you see mass under mass. So 96 gram, I don't know the molecule, that I don't know the atom. Can you see atom under atom? This atom under atom, mass under mass. So 98 gives me 6.02 times 10 to the power 23, which is the same thing as saying that 1 mole is equal to this. But I don't know what 96 gram will give me. So 96 gram will give x. So from here you cross multiply. So x is equal to 6.02 times 10 raised to the power 23 times 196 all over 98. So from here, so x should be equal to 1.204 times 10 raised to the power 24. Now, so this is what you ought to get. And let's say you want to use the first method I use. Maybe you want to use the mass, or maybe you are thinking that, okay, what if I use the mass to mole relationship? Yes, you are still going to get the same thing. Let's solve it together. So from what I've taught you so far, if you want to use mass to this, so what you're going to do is that you will first find the mole of this particular guys. So you are given mass. The mass is 196 gram. And don't forget that the molar mass of H2SO4 is 98. So you find the mole is equal to mass all over molar mass. And the mass is 196 divided by 98. So I believe this should give you 8 plus 16, 9 plus 9, that should be 18. Yes, so it means it is 2 mole here. So now once we have gotten it, this is mass, we have molar mass. So mass over molar mass, we find the mole. Then you will say that 1 mole should give 6.02 times 10 raised to power 23. So then this is 2 mole. So you don't know what 2 mole will give you, x. So you cross multiply. So x times 1 is x. Then 2 times 6.02 times 10 raised to power 23. 2 times 6.02 times 10 raised to power 23. We give x to be equal to 1.204 times 10 raised to power 24. So that is what we are going to get. I hope that is clear to you. So it means that any of the formula you use, you get your this. Yes, so I guess this should be the last one. That is using volume at STP. Yes, this guy is actually quite very interesting, and it's quite one of the best formula I love in solving mole concepts. Yes, you need to understand that you can only use this formula under 2 conditions. Number 1, if you are asked to find volume. If the volume is under STP, please, if the question does not say that, if the question just say that calculate the volume and STP is not measured, don't use the formula. But if the question says that calculate the volume liberated at STP, calculate the volume blah 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 at STP, volume this at STP, then you can now use this particular formula. And what is the formula? The formula is equal to, okay, before I give you the formula, you should know I love explaining the theory aspect of it. So the mentality here is that just like how 1 mole of any substance is equal to its exact molecular mass, how mole of any substance is equal to 6.2 times 10 to the power 23. So according to scientific experiment, it is believed that 1 mole of any substance should be equal to 22.4 dm cube. So that's it. Look at it. Don't forget I told you that 1 mole is equal to exact what? Molecular mass. And I told you that 1 mole is equal to what? 6.02 times 10 to the power what? 23. So it simply means that 22.4 dm cube is also equal to exact molecular mass of any substance. So 22.4 dm cube is also equal to 6.02 times 10 to the power what? 23. So they are equal to themselves. That's the meaning. So okay, so let's move. Let's use it to solve. But don't forget, I will repeat myself again. The condition here holds at the fact that if you are told that you should calculate the volume at STP, if volume at STP is not measured, don't use the formula. You are wrong. Now look at this, my beautiful question. The question measured that calculate the volume occupied by 3 moles of carbon dioxide at STP. The question measured volume and it measured what? STP. It means I'm to use this formula. I can remember some days ago I was teaching some students on how to use Gay-Lussac law to solve some questions in chemistry, and I saw a particular student that was trying to do as if he knows much, and before I know he started using this particular formula. I said no, this is very bad. Many students, I know many of you that are even seeing this or watching this, I know you will know this formula, but many of you do not know when to use it. Please, you are meant to use this formula if the question says you should find the volume at STP. So if STP is not measured, don't use it. So there are 2 ways by which I will solve this. So I would love to use the theoretical explanation I explained above, and which I did. Can you see 1 mole is equal to 22.4, or 1 mole is equal to exact molecular mass, or 1 mole is equal to 6.02 times 10 to the power 3. Or there is a formula approach to it too, just like so the formula is that mole is equal to volume all over 22.4. So that is if it's in dm cube. But if the volume is in centimeter cube, it will be V all over 22,400. That is in centimeter cube. I hope that is clear to you. So please feel free to write the formula down. N equal to V all over 22.4 dm cube, or N equal to V all over 22,400 dm cube. So the first thing we do is to write our solution. So the question says that we should find 3 moles. What 3 mole of the volume that 3 mole will give us? We have known from our understanding that 1 mole of any substance will produce 22.4 in dm cube. Can you see that? So 3 mole, what will 3 mole give us? We don't know what 3 mole. So what will 3 mole give us? We don't know. So 3 mole will give us what we don't know. So we cross multiply. So x times 1 is x. Then 3 times 22.4. So 3 times 22.4. So I guess that should give, that is 2 point, that is 3 times 2, that is 6, 7, that is 67.2 dm cube. So, or you can use the formula method. You say n equal to v all over 22.4. So don't forget, so you bring out your parameter from the question. N is equal to 3. We don't know the v. We have to calculate the volume, but we know that we know 22.4 already, which is called the gram molar volume. So sometimes we could put it as n equal to v all over gram molar volume. So gram molar volume is 22.4. So here, so we have n equal to v all over 22.4, and from here v is equal to n times 22.4. So v is equal to 3 times 22.4. And you can see they are the same thing. 3 times 22.4, 3 times 22.4. You get the same answer. So let's look at this guy here. So we are asked to calculate how many grams of gas are present in 500 centimeter cube of this place is of chlorine gas. So how many grams of gas are present in 500 centimeter cube of chlorine gas? So don't forget here now. See, this question is very simple because the question is using gram to volume relationship. I've told you, so learn to be smart and be fast. So I've told you that if 1 mole should be equal to 22.4 dm cube, then 1 mole as well, it should be equal to exact molecular mass. So it means the exact molecular mass of any substance should give you 22.4 dm cube. So because we are doing molar mass and volume, so that's what we're going to do. Don't forget that chlorine gas is Cl2, and it means 35.5 times 2, which is equal to 71 gram per mole. So instead of saying that 1 mole of chlorine gas will give me 22.4 dm cube, but because this volume is in centimeter cube, so I'm going to use centimeter cube version, which is 22,400. Is there upward? So I've told you, if you need centimeter cube, so you use 22 digits, you use 22,400. If you need dm cube, 22.4. So the unit must be the same. If you are using centimeter cube, use centimeter cube. If you are using dm cube, use dm cube. So that's it. So the secret here is that to convert centimeter cube to dm cube, you divide by 1000. Dm cube to centimeter cube, you multiply by 1000. So that 22.4 was multiplied by 1000 from dm cube. It took it back to centimeter cube. That's how we have 22,400 centimeter cube. Now, so from here, we have 1 mole to produce 22,400. So don't forget, instead of writing 1 mole, we know that 1 mole should give the exact molecular mass. So we just say that 71, which is exact molecular mass. So instead of writing 1 mole, we say that 71 grams should give 22,400. Then we don't know the mass that 5,600 will generate. Can you see it? So we cross multiply. Then from there, x is equal to, so you cross multiply, is equal to 71 times 5,600 all over 22,400. So you punch this in your calculator and you obtain your answer. I hope it's clear to you. So instead of writing 1 mole contain 22,400, so 1 mole is already the molar mass. So the molar mass of this one, we don't know what the 5,600 will produce. Now let's move on to the next one. So if you want to copy this, feel free to pause the video and copy it. So the next one talks about calculate the number of mole of hydrogen gas present in 2.24 dm cube of this. Calculate the number of molecules. Yes. Now this go back to my friend, which is Avogadro's entities. Calculate the number of molecules. You can see because this question mentioned molecules. I repeat, because the question mentioned calculate the number of molecules. And molecules is an Avogadro's what? Entities. So it means that this time around I'm using 6.02 times 10 to the power 23. You see that so far so good, I've not been using 6.2 times 10 to the power 23 because the question does not measure ions, atoms, or molecules. But here it is measured. So it is measured. So it is mentioned that I should find the number of molecules. It means I'm going to use Avogadro's. So I know that 1 mole of any substance should produce 22.4 dm3. You can see this type of question, they are very interesting. You don't even need mass because the question does not need anything about mass. If you are finding molecular mass here, you are deceiving yourself. You don't need it because the question is quite very straightforward and very interesting. So we know that 1 mole of any substance should be equal to 22.4 dm3. And don't forget that what does the 1 mole mean? 1 mole of any substance is equal to 6.02 times 10 to the power 23. Why am I changing to 6.02? It's because it is number of molecules we need. So we don't know the number of molecule under molecule. Can you see? We don't know the number of molecule that 2.24 will produce. So we know that 6.02 times 10 to the power 23, which is the same as 1 mole or exact molecular mass, we produce 22.4, but we don't know the molecule that will produce 22.24. So from here, you will then cross multiply. So when you cross multiply from here, x will now be equal to 6.02 times 10 to the power 23 times 22.4 all over 2.24. So x is now equal to 6.02 times 22 to a molecules. So I hope that is clear to you. Feel free to pause the video and copy it. So the last one now is dilution formula. So dilution formula is actually the last one. And when I mean dilution formula, yes, it's something we know very well. We are all familiar with C1 V1 is equal to C2 V2. Yes, that is a dilution formula. Very interesting. So the mentality of this thing is gotten from dilution formula, because we believe that if 1 mole of a substance is equal to, that's what Avogadro is trying to say, that equal volume of all gases at the same temperature and pressure must contain the same number of molecules. That is, if 1 mole is equal to another mole 2, then what is mole? So mole, from this mentality, we can say that mole is now CV, and that's where we are going. The dilution formula says that mole is equal to CV. So mole is equal to CV, so mole of N2 is also equal to C2V2. So that's what we're doing. So the formula is now in 2 phases. Please, I need your attention because you need to know when to apply any of these formulas. So we have N to be equal to CV. So you are to use N equal to CV if the volume is in dm cube. But if the volume is in centimeter cube, so you will use N equal to CV all over 1000. So this is when the volume is in centimeter cube. So please take note of that. So you really need it. Take note of that. So now let's look at this example, then we are good to go. Yes, so we are asked to find the number of mole. Can you see this is another thing entirely? Finding mole in another aspect. That's the reason why we call it mole concept. Calculate the number of mole present in 5 liter. Yeah, 5 liter is the same thing as 5 dm cube. Don't be scared. So we are asked to find the number of mole. We don't know what the number of mole is. So we are asked to find the number of mole present in 5 liters. So the volume is 5 liter. So, but the concentration, we are given concentration. So 0.2 molar, it's the same thing as saying that 0.2 mole per dm cube. Please take note of that. So because our volume is in 5 liter, that is in dm cube. So don't forget, I told you that it also means dm cube. So 5 dm cube. So N is equal to CV. Then from here, we are looking for N. N is equal to 5 times 0.2. And the number of mole is equal to 1 mole. So you can say not divided by 1000. Why? Because the volume is in dm cube, not centimeter cube. So, okay, I believe that's all we have here. So thank you so much for waiting up to this extent. So ensure you subscribe to the YouTube channel, forward it to your other friend as well, let them benefit from it. Thank you so much for your time.